Okay, I want to look at solving absolute value inequalities when the right-hand side is negative. Because this leads to some interesting solutions that we need to learn to recognize and understand. Yeah, that's all I want to say about that. So let's first just remember that to do this, the absolute value represents distance from zero. You know the absolute value of an expression, you know how far it is away from zero. Distance can't be negative. It doesn't matter which direction you're going, it is the same distance from point A to point B as it is from point B to point A. You don't talk about negative number of miles as between two cities. So distance is not a negative quantity. And the other thing, excuse me, that we need to think about is what quantity we're looking at when we have a less than sign versus a negative sign, versus a greater than sign. So in other words, if I have something like this, the absolute value of f of x is greater than a. So that what that's saying is that the distance between f of x and 0 is bigger than some number a. So what that looks like on a number line, let's just assume that a is a positive number to make this a little bit easier to think about. Here's a, and over here's negative a. 0 is right in between them. So that this represents a distance from 0 of a, but this also represents a distance from 0 of a. So what we know is that for the distance for f of x's absolute value to be bigger than a, f of x has to fall out here. F of x can be out here, or it could potentially be out here. That's the only way for it to have a distance greater than a. So this translates into two inequalities. F of x is bigger than a, or f of x is less than negative a. Now, if we flip the inequality around and we have absolute value of f of x is less than a, well, that means our distance from 0 to f of x has to be smaller than a. And in that case, f of x must be falling in this region right here. One of those two regions, which translates into negative a is less than f of x is less than a. All right, so we have two different translations. But sometimes we run into a problem where once we've simplified it, the value on the right is a negative number. So for example, in both of those cases, I assumed that a was a positive number. So now I want to look at what happens if a is negative. All right, so for example, what if I have a problem like this? 3 times the absolute value of 2x plus 1 plus 9 is less than 6. Now, at first glance, everything looks good here, right? I have a nice positive number and it looks as if I can proceed. However, we know that we can't really do this problem. So in this case, my f of x is the 2x plus 1. It's a nice linear function of x inside my absolute value. I can't really proceed here until I move some things around, until I move, get that absolute value isolated. So to do that, I'm going to move the 9 over, but that's not what I'm going to get. I'm going to get a negative 3 when I do 6 minus 9, so I've subtracted 9 from both sides there. And then I'm going to divide everything by 3, and now I have the absolute value of 2x plus 1 is less than negative 1. Now, we have to think about what that means. This is telling us that this expression is less than negative 1 units from 0. So it has a distance smaller than a negative number. We already said distance can't be 0, so this is problematic. This is not a good thing. We cannot have a distance less than negative 1 because distance has to be 0 or bigger. That's what it means to talk about distance, and therefore that's what it means to talk about absolute value. So when we have an expression like this has no solution. Or if you want to be formal about it, the solution is the empty set. There are no values of x that are going to make that expression inside those absolute values be a distance away from 0 of negative 1. That physically cannot happen. But notice that if we flip it around, so I'm going to take the same problem, make it a greater than sign. Oops, subtracting the 9, so I get a bigger than negative 3, and the absolute value of 2x plus 1 is bigger than negative 1. So now I'm asking what values of x make this so that it is a distance of more than negative 1. Well, everything has a distance greater than negative 1 from 0 because distance is positive. So this time our answer is negative infinity to infinity, or we can say all real numbers if we want to. Every real number will be, so that if I stick it into this expression and take the absolute value, the number I'm going to get is bigger than negative 1, because that's how absolute values work. So hopefully that clears up any issues you might have been having trying to figure out what to do when you have a negative sign on one side of an absolute value inequality.